Hi, this is Stephen Brower from Raton Valley Community College. This is, I guess, an addendum to part one, specifically at showing a tree being built from scratch. And the nodes that are on here match what's going to be in part two of part one on trees. Whoops. Okay, so suppose we're beginning with, we initially have an empty tree. And so root here is pointing to null. And then we want to add, in this case, 38 to the tree. Well, let's get rid of this. This will create, but we're going to see something else, so look at the code. This is just going to be the manual part. We'll take a look at the code in another video. Okay. So root is now going to point to 38. Whenever an add is done, we always begin at the root. And so at this point in memory, root would be pointing to 38. Now I'm not going to show it here, but the left and the right of 38 are both going to be null. Suppose the next add that takes place. So let's say we call the add method again, and this time we pass in the value 62. Well, we always begin by looking at the root. So we begin by looking at the root, and then we compare the 62 to the 38 that's here. Well, 62 is greater, so we look at the right link. Well, there is no right link, so a new link is going to be created from the right that will have the value 62. So this is being created from the right-hand side. Okay, and that ends the add method with the value 62. So suppose we call the add method again, and we have the value 11. Remember, we always begin at the root. So when we're beginning at the root, we're comparing the 11 to 38. And 11 is less than 38. When we look left, there is no left link. So a new node will be created from the left of 38 that has the value 11. And so just remember that the add method is always going to begin cursor equals root. It's always going to begin by looking at the root. So now if we have 5, so again, we're coming in, cursor is starting off at root, and so we're looking at, oops, I lost my mouse again, I'm sorry. We're looking at 38. 5 is less than 38. There is a left link, so cursor will go along, cursor equal cursor get left. So now we're looking at 11. 5 is less than 11. We look left. Well, there is no left. So then the left is going to be created pointing to this new node 5. And that ends the add method with the value 5. So now suppose we call add again. Now we have the value 21. And again, remember, we're always beginning at, I lost my mouse again, I'm sorry. We're always beginning, I lost it again. We're always beginning at the root. So 21 is being compared to 38. 21 is less than 38. Well, we have a left, so cursor equal cursor get left. And then we're comparing 21 to 11. Oh, it's greater. Well, there is no right. So to the right of 11, then this 21 is being created here. And so what we have now, after this add method with the value 21 has been called, this is how the tree looks right now. And then just, assuring, when we look at it from every node's perspective, everything to the left is less, everything to the right is greater. So from 38's perspective, the subtree to the left, everything's less than or equal to 38. From 38's perspective, everything to the right is greater. From 11's perspective, everything to the left is less than or equal to 11. From 11's perspective, everything to the right is greater. So we maintained this binary search tree order. So there's going to be another video, which is a continuation of part one, that has an add algorithm, and it will trace through the add algorithm for the adding of 7 Wait, do I have 7? Oh, I forgot. Adding 7. So, there is 7 here. So there'll be another video that will go through the adding of the 7, but looking at the algorithm. But again, we'll begin. We compare the 7. We always start off at the root. Cursor equals root. And so the 7, well, 7 is less than 38, so we go left. 7 is less than 11, so we go left. 7 is greater than 5. Well, we can't go right. So then the new link is created to the right of 5, which has the value 7. Okay, and we're still maintaining the binary search tree order. Everything to the left of 11 is less than or equal to 11. From 5's perspective, everything to its left, well, there's nothing, is less, but everything to the right, we do have the value 7. Okay, so anyway, this other video will take a look at the add algorithm and show the adding of 7.